Hello boys and girls, I am the Guide Knight and welcome to part 2 of my GDScript for beginners series. GDScript is the default scripting language used by Godot engine, and Godot engine is an open source game development engine. In this series I am showing you basically very basic stuff and explaining some of them, how they work and what they actually mean. Last time I showed you about arrays, dictionaries, typed and untyped variables like integers, basically numbers, a string, which is nothing else but a text or a sequence of characters. And we talked about indexes and whatnot. So in this case, in this episode, I'm going to extend a little bit the knowledge about arrays and dictionaries and continue on with further information. So what did we miss last time? We missed that we didn't show actually how you can add more stuff to the array or the dictionary. Like you can extend it with another variable, but this is only static instantiation, right? So let's go ahead and get rid of everything except the array and dictionary. So I'm going to start with an empty array and maybe add one just to test it first. Number one. So I'm going to basically iterate over the array, and in that case the for loop, this is called a for loop, which iterates over the values of the array. So I'm going to go over each of the values. In that case it's going to be only one, and I'm going to print the array value is, and then concatenate it with the actual value. So this is everything, and I expect only once to print the array value is 1. Yep, this is what is going on. If you're wondering what I'm doing, I'm actually pressing F5 or running this play button, which is running the script attached to my main world scene in Godot. In my case, it's actually called world. And you can change this by editing. You can change it by editing the project settings, and from application you can go to run and you see the main scene is defined here. You can change it to something else if you would like to have a different scene. All right, so how do we add more stuff to the array? It's very easy. You just use the append function and appending stuff, and then I can append some more and some more. So in that case, I would expect still the 1 to be there, and then the second one should be this one, and the third value should be and some more. So let me run it and see. Yep, this is exactly what's happening. And if you're wondering like, append, how do I know this magical keyword? It is very easy. You can see it either by clicking on it and going to the documentation, or you can just go to search help, then type array, and then click here, and then you will see the description of the array. You'll see some examples. For instance, this is like a static definition, then they're printing some values, and then basically it's printing the last, like from the back, basically -1 means like it starts to count from the end till the start. So it's printing the last value basically, if you want, with -1. And you can also see some methods. One of the methods happens to be append. And if I like click on this method, you see like appends an element at the end of the array. And there is also append array, which appends another array at the end of this array. So let's go ahead and try this, right? I'm gonna create another array, second array. Maybe I should stick to snake case and not use camel case and snake case at the same time. If you're wondering what I'm talking about, I don't know. Basically, just let me create the array, then I can think again. All right, so basically snake case is using underscores, and camel case is because of the humps of the camel, and the actual word looks like there is a hump and there is another hump. That's why that's called camel case, and this is called snake case because it crawls on the ground. Like this is snake case, the other one is camel case. So I'm gonna use snake case for this example. I think actually Godot mostly uses snake case as a convention. I'm not 100% sure that. Anyhow, you can use whatever you want, I guess, as long as it's consistent. Don't switch to snake case and camel case in the middle of the project. That's gonna be weird. I'm gonna probably do it. Don't point. Anyhow, so if I now run again, nothing will change because I did not append the array. So I can use the append array function and then append the second array. In that case, I would now expect 5 values in my first array. Like, remember, I'm only iterating on the first array, and now I'm getting the 5 values. All right. The dictionary is more likely an array with key value pairs, or like kind of a map in some other objects, or some other languages, sorry. And you can put like different keys, different values. Basically, this is called a variant. If you want to look for variant, you can also look at the documentation here. The most important data type in Godot. In computer programming, a variant class is a class that is designed to store a variety of other objects. You can think of the var actually as short for variant, I guess. It's a variable or a variant. In that case, the variant here is 2, the number 2, then it's changing to a string, and then it's a reference of a new object, so a new object basically. So yeah, variant is what you can put in arrays and dictionaries, so you can put other objects as well. We're gonna show maybe an example later on, but let me just tell you how to add stuff to the dictionary. By the way, I can also look for array here in the online documentation that I showed you last time, Godot docs. You can just type in array or just go to the thing. It's under the Godot API, and then click on it, and then you see the API here. Like the array in that case is basically the same documentation we kind of saw in the editor. So that's very helpful. You can actually you can compare to arrays, I guess. It's comparing cardinal to algebraic. I guess this is a function. I'm not sure if this is actually... Okay. I don't know if this is a custom function or not really, but you can actually compare arrays with equal operator. So if I like print, let's say array string equal array string 2, and I'm just gonna remove all the stuff, or comment it out with Control K. Then I'm going to copy this, and let's have more elements like 5 and 5.1. Let's see if they're gonna be equal. Right? I'm comparing it, and it is false. But if I compare it like that, it should be true. Like basically it is comparing each element, I guess, one by one. Usually in Godot, you compare objects by their hash or their reference, like they reference a certain thing. If it's an object, it has a reference ID yeah, it's basically probably the in-memory reference of that object, basically the data address of that object, and then it can compare it. I may not be entirely correct in that, but basically it's compared by reference. This is definitely so. For arrays, it's compared by values, so it's actually comparing them one by one. If you want to create a function that compares them like this, you want those two to be equal, right? In that case, you can create your own function to compare them, and you can just use the naive approach to iterate over the first one and then iterate over the second one. So let me just quickly implement that to show you basically naive comparison. A1 and A2. This will be array 1, this will be array 2. And then I can say like 4 value in A1, and then 4 value 2, maybe V1, for consistency. Consistency is very important, guys, in A2. And then I can have like for each I can have like variable. How am I gonna figure it? Okay, so I'm going to go through all of the variables in the first array, and I will have to look for them in the second array, right? So I would expect that if v1 equals v2, so if the variables are equal, then I would expect to have a match, right? Like a variable found. So in that case, I will have a variable here, variable found, it will be false. And in here, I will have like a total match variable, which will be, the first one should be also maybe false, right? Or let's think about it. Okay, so I'm gonna go over each, like this is found, and if there is a found variable, I can also do break. This break means that it will cancel the rest of the for loop. I don't need to look any further because I already have a match. Can I look at the keyword? It doesn't show any documentation, but this is what break means. Like if you're in a loop, you can break. This means that it will get out of the loop. And the other keyword is continue. This means that if you have more code here, like, I don't know, pass, some other code, except pass, continue means that it will actually pass over the rest of the code. Like if I have like prints and so on, this will just skip this code and continue with the next iteration. And break is what I want to do in this case. It means that it will get out of this loop and continue basically on the next line, right? So in this case, I have found my one variable, and if this is not found, so if I don't have a like my variable found, then I will say total match equals false. Okay, I guess we'll start with true. So I have like, okay, I'm sure that this is no longer a match because I have one variable v1 that is not present in the second array, right? So the total match will be false in that case. And of course, I can also like have an edge cases like I can compare the length of the arrays. Like I think if len, if I'm not mistaken, len was the function, a1 equals len a2. I can start with that because this is easy to compute, right? I don't have to do the n2. If you like doing computer science annotations, this is n squared. So the algorithm intensity of this comparison, that's why it's kind of naive. But I can skip this by just comparing the length. If they're not the same, I can say, okay, it's not the same. But if they are the same, I compare them one by one, and I expect always to have a total match. So then I, in that case, return total match. So amazing algorithm programming directly without any preparation. So probably it's gonna be completely wrong. Anyhow, let's see if that's true or not. Like I'm gonna compare my two arrays with the equal operator and with my function. I still haven't talked about functions, but okay, so in that case they are both false. Why are they actually both false? I would have expected the second one to be true. Like, oh, I can actually show you a really interesting thing. It's called the debugger. I think you can create, you can click here in the field, and you can add different debug points. And if I now start it, it will go here, and then it will enter and stop on the debug point. I'm just starting with F5. And right now I am here in this location in my debugger. And you see my local variables here. I can see my first array and my second array, like A1 is having those properties, A2 is having those properties. So I see they should not go here, right? So if I go to the next one, continue is F12, what is the step over? Step into. So basically step into is if you have a function call, you want to go into maybe the length function. Step over is just go to the next line in the current scope. and continue is go to the next debug point. So I'm gonna press F10 or click here, step over. And in that case, I see, okay, I have like v1 right now is equal to 1. And then I have v2 is equal to 5. In that case, this should not be true. So I will continue, like it should be false initialized, but I forgot to initialize it to true here. Of course, I thought I did, but I didn't. So basically when you find it, basically it says, okay, it's found now. And this should actually fix it. It's now false, and if I change it to 5, it'll be true. I can add more, like 1, maybe 2, 4, and then I can maybe add 4, 2. Yep, like that. It'll still be true. And if I change this to another 2, it should be... Ah, okay. That is not entirely correct. Anyhow, I guess the algorithm is a little bit more complex if you have like repeating numbers, right? Because the 4 is or the 2 is already present, so it says, okay, I have it. I have the same number of characters, but some of them are repeating. So if I have a 7 and I don't have the 7 here, it will be false. But if I have a 7, it will, yeah. So anyhow, that was only a very brief, that took already so many minutes. Escape into showing you that how you can like compare them with your custom like function. Basically, if you want to compare them completely correctly, you need to also count how many of the variables you have been expecting and how many you actually found. Right now, if I find 1, I say, okay, this is there, but maybe I need to find 2 more, 1s or 2s or whatnot, if I have values that can repeat in the array. So let's go ahead and continue with the dictionary. Let me show you how you can go to the dictionary in the documentation or dictionary inside Godot, the editor, how you can add more stuff. You can think, if I'm not mistaken, let me get rid of the arrays. If I'm not mistaken, you can just let me iterate over the dictionary, key in dictionary, and then print string key, and then value dictionary key. So this should be printing the key and values. And if I want to add more stuff, I can say like dictionary blab equals this was just added, like just like that. Yeah, this is basically how you add stuff. And if I would like to remove stuff, maybe I can just say, let me see actually how do you remove stuff from dictionary. I don't, maybe just initialize to nil or something. Clear the dictionary, moving all, okay. You can clear the dictionary, removing, you can empty it, you can, okay, you can erase. So I need to pass in the key, what I want to erase. So I can say like dictionary.erase and then say blah, right? So I just add it, or maybe I just erase the key and not the one that just added. So this one should be gone. Yeah, the 2 is the only key and the blah is the second key, and I erased the key. So this is how you operate dictionaries. As usual, just look at the documentation. It's super useful, super helpful. There are like tons of examples. For instance, you can also like have a dictionary key and value here and another dictionary, and you can like compare them. And yeah, let's run this this example shortly. Like I can also tell you about the export keyword. It's quite helpful. Let me just go here and remove my ready function, because already having, or it's already coming with the ready function. Amazing, right? So what does it do? Like, first of all, it gives you a expected a constant expression. Huh. I did not expect actually their example code to not be compiling. Okay, it took me a while to figure it out actually, because searching for export in the documentation is actually not that easy. There's a lot of exporting the projects, there's the export keyword, but for C# for some reason, and exporting projects for web and whatnot, actually also useful stuff, but what I was actually looking for was GDScript exports. And you can see some documentation about how the export keyword works, and documentation with string, and you notice the string is uppercase. So let me go ahead and fix that. And what it does is actually, if I go to my 2D editor and I click on my word, I'll see my color here. This is like exported from here. If I can like have another export, like another export, and I have like 1, 2, 3 or whatnot. In that case, I will see it here, and I have the option to actually choose one of them. Maybe I can have a 4, and this will basically, I can select it, and this will be visible and usable in my script. So what this does is actually it allows you to pick from white, yellow, and orange, and it assigns certain points from the dictionary to this keyword, and then you can basically get the points from the dictionary by the keyword. So if I just run it like that, though, it may not really succeed because it says the invalid index. And for this is because this is actually not initialized. I'm going to initialize it with white, and then it should work. I can then print my points. In that case, I should get 50 points for white. Yeah, 50 points. And if I actually change it here, it will overwrite the data that I set here. So it will be yellow instead of white, despite the fact that in the script it says white. And then I should have 75 points. There we go, 75 points. So that's it about dictionaries and arrays. I guess this is, enough for now. Where did it go? Anyhow, you can actually open it here directly by clicking on the online documentation, and then you can, yeah, it will open the stable branch here. So it's already like 20 something minutes. I will, again, I'm going way too slow, but what do you know? Anyhow, let me talk briefly about enumerations. Did I talk about them? Well, they're basically numbers, so to say. Like you can have a name, and basically each of them has a value, and the value is a number. So if I just print this, I should be getting 0, I think, if I'm not mistaken. I get 0. And you can compare them because they are numbers with pretty names. You can instantiate states and whatnot. And yeah, I guess did I already talk about them last time? I don't remember. Anyhow, they are not that great to talk about. I mean, there is equivalent stuff in Java and other languages. It's there. The nice thing is that they're constants. Like the constants here, they don't change. Like the difference between a variable and a constant is that the constant you cannot change. Like, and oftentimes the constant is written with uppercase, with camel, with snake case, like all uppercase words with camel. Nice to do the same error twice, but yeah, uppercase words with snake case. So the answer is 42, and if I try to change the answer to something else, I will not succeed, guys. You say can't reassign the value of a constant. So if you define a constant, you pretty much know the answer, or pretty much know that it is not being changed. It's actually useful for load errors. It's actually useful for immutability if you want to have some sort of objects that don't change their state and so on. The same can be applied for strings as well, also constants. So if you don't expect the value of something to change, I strongly advise you to use a constant and not a variable. And enumerations are really nice for maybe keeping them as keys for stuff, because they have a, like, this enumeration can only have like those 3 values. And the named enumerations, yeah, I remember what those were. This can be like, I can access this enumeration like that. Just use the name inside the GD script, but I cannot access this, the second enumeration like this, because it says, oh, I'm not familiar with this identifier. I can access this with the prefix, like this is the named, in that case it's a prefix. And I say like, it can be like things. And if I rename this to things, I'll say like, okay, things.thing1. And in that case, the things.thing1 should be also 0, I think. Yeah, it's 0. But the useful things about having the named one is that you actually know how to access it. And you can have like multiple other things. Yeah, if you notice that I keep everything in like snake case, but the enumeration names and the class names, I think I use camel case for some reason. I don't know. Yeah, but like I can access the things and things one, and I have like different stuff here. Like you can type whatever you want. They're basically numbers with pretty names. Useful for a lot of cases. I think I will try to go over the vectors and explain what the function is, and then go over the like more of the functions later on. Sorry about being so slow again. I always think like, oh yeah, that's super easy. This is gonna take like 1 minute, and then it takes 30. All right, so a vector is something very useful for, like, you can define velocity. So if I were to add here something like, let's say I'm gonna add this icon, right? And then I want to access this icon from here. If you're not familiar with what I'm doing, it's fine. I'm just gonna grab the icon. This is the way you can do it in Godot. Basically, with $, you can access stuff that you added in your tree. And with onReady, you tell that basically it's a keyword. Without it, it may not be initialized. So this way is basically telling us, wait until this object is initialized, and then you can use it. And if as I'm using it in the ready function, this should already be fine. But in that case, I'm not going to use it in the ready function. I'm going to use it in the another function like a physics process. This is another, I need to add the pass keyword here, otherwise it's going to break. Physics process, this is another predefined thingy. You can read about it. It's basically being called about once, 60 times per second, if you have like defined 60 frames per second for your game. So the delta is basically the time that elapsed since the last call. In some cases, your computer can stutter and the delta can be different, but usually it should be 1/60th, like 1/60th of a second, the delta. So I want to move the icon right now, and I'm going to use this as a vector2. Like vector2 is basically two-dimensional vector, right? It has a x and a y dimension, right? If I am an open GIMP, for instance, the vector2 will have, let me open GIMP in this window and create a new something. Basically, I have like an x and a y axis. This is like my x and this is my y. Amazing. Y axis, and the vector2 would be basically this one with the direction, or this one with the direction, or this one with the direction. And if I were to have a z axis somewhere here, then basically any thing that is having like dimensions in all 3 axes. Let's say this is like here in the z-axis or so. I don't know. It's not really the best drawing ever, but you get this like vector3, and the other one with 2 axes is vector2. And this is the x-axis, this is the y-axis. For 2-dimensional games, it's very useful because you can use this for velocity. I oftentimes define my velocity as vector 2 because this is what the inbuilt program functions of Godot use as well. And I can say I would like my icon right now to move in the x direction. So my vector in that case is like 10. Let me clean this up. So like it has like it's like 10. It has 0, y, and 10. So it goes to the right basically with a steady function motion, right? So I can say like I will, but of course I cannot really do that, and I can actually still do it, but I would prefer to have like a kinematic body. Just let me add a short kinematic body here and add the icon to it. Kinematic body is basically something you would usually use for a player, and I can add the script here. I'm going to copy my already here in this script, and also the physics process, because I don't want the world to move. I want actually only the player to move, in that case the icon, right? So if I have my where is my velocity? I also forgot my velocity. So if I have like this velocity, I can simply say, okay, move and slide. And I can give the linear velocity, which is the vector 2. Basically, the move and slide is function of the kinematic body 2D. The kinematic body 2D is something you use for your player usually, or some other stuff that you control in some way. There's like a static body 2D, and rigid body 2D. Like you can like read in the documentation what each of them are. For the purpose of this demo, I'll just use this, like move and slide. If I apply this, then my icon will be moving right if I start the game slowly. If I increase the velocity to say 50, it will move faster. And this is basically why for what you use the vector. If I add some y velocity, it will also move in the y angle. You notice that it's not going up because the y in that case it's increasing downwards and x is increasing rightwards. So if I make it 50-50, it will go diagonally to the lower right corner of the screen, basically. Yeah. So this is a vector. It's an object as well, like kinematic body 2D or my node object that I showed you before. You can click on it and you can read like stuff like that, like the functions. There's like, for instance, the clump function is a very useful one. Returns the vector with the maximum length by limiting the length of vector. So if you like have like a circle or so, and you would like the length of the vector to always be 1, you can just say, okay, I have a slightly longer vector and you don't need to do any super weird computations, and you would like to clamp it to length 1, basically. I'm sorry about the poisonous color, by the way. I don't know. If you want to like clamp it to length 1, you would just use clamped and it will be of length 1. Like I can actually clamp my velocity right now because 50-50 is not, it's actually a square, right? So it's longer than if this is 50 and this is 50, it's longer than 1, right? Definitely. But I can clamp it to 1 and then multiply it by 50. So I can just do velocity clamped 1, and then I can multiply it by 50, like velocity equals velocity times 50. Like you can multiply, and then I can actually print it to see my velocity. It should be, all right, this didn't really work out exactly. You see that velocity is actually always increasing because I should have done that in the ready function and not in the physics process function. The reason for that is that this is code multiple times and this is code only once, and I only want to do that once, right? So let me just do it once and then it should be fine. Not really. If I do it like that. yeah, it's returning the clumped vector. So I need to actually assign velocity to the return value of this function. And it is clamped to 1. See, it's not like 50-50, it's 0.7. And then I can multiply it by 50. And it will be 35. So this is like normalized, so to say, speed. I use this in one of my tutorials for the breakout game. If you watch this, you can see the clamp function being used there. So I already talked some about the functions. I showed you a lot of them. But what is a function basically? It is a mathematical construct where you have a name, like this is the name of the function. You have some parameters and you have a response that the function returns, and you can reuse it multiple times. That's the beauty of the function. You can reuse it. Like I can create a function like print name, and I can have a name, or like print greeting. The most common thing in programming languages is like hello world, right? So I'm gonna just say like hello, and you concatenate, of course, name, hello, name. So it's actually not printing, like get greeting, and I can then I'm kind of abusing my Kinematic Body today, but it's fine. I can print and then get greeting, let's say John, and then I should see hello John, right? And I can use the same thing to greet another person, like Albert, for some reason. And then you see Albert. And the beautiful thing is that if you have a problem with the function, you can fix it only in one place. Like here, I forgot to add the interval after the comma. So if I fix it here, I will see hello John and hello Albert. And I can use a greeting to apply something like multiple times. So like, I don't know, function, I don't know, count to 10 or whatnot. And I can, okay, maybe something with the return value. Like I would like to multiply, very simple. You can type in the return type like that, and then return a times b. In Godot, you don't have to type in the return type, but if I return something else, this may cause problems. I expect, yeah, the return type value of type string doesn't match the function return type integer. So this is another check you can add. Like if you're absolutely sure what your function returns, it's always nice to add it. I don't always do it because I'm a little bit lazy sometimes, but it's a good practice. So I can just use this and say like print how much is, I don't know, 7 times 8, and then answer will be just multiply 7 and 8, right? You separate the different arguments of a function with a comma, and then you can directly use the return type. Like if I run it right now, this will type 56. It's basically the same as if I just type 56 here, right? This is the return type. Like this function is being resolved on runtime, and its return type or return value is being inserted where the function call is called. Like I can also type answer, and the answer will be multiply 7 times 6, and in that case I will have a variable with the result of this function, basically with the return integer of this function, which is again 56. And I can also, I think, have a constant that holds, okay. Parsing expression misplaced constant, okay. Probably I cannot have a constant here, but I can have a variable. Yeah. So I guess this is it for today, guys. Again, a very long video. I'm really sorry about that. I hope you did enjoy it. And if you have any questions, don't hesitate to ask me. I'm always fond of answering questions, especially if I can answer them. Those are my favorite questions, guys. but also questions that are not that easy to answer. It's really nice when I learn something, when I actually look for the answer. So stay cool, stay awesome, as I know you are, and see you guys next time. Bye bye.